Today, we will be covering the essentials of application security, focusing on practices and techniques to secure applications throughout their development and deployment. First, let's talk about the Software Development Lifecycle, or SDLC. Think of it as a mission plan for developing software, guiding us from planning to deployment and maintenance. It includes several common steps: planning and defining goals and requirements, determining what the software needs to do, creating blueprints for how the software will work, checking for bugs and vulnerabilities, preparing users and moving the software into operation, keeping the software running smoothly, and safely retiring the software at the end of its life cycle. Next, we use various environments for code deployment: development, where code is written; testing, where code is tested; staging, a pre-production environment for final testing; and production, the live environment where the software is used. DevOps focuses on improving collaboration between development and operations teams for faster software delivery, while SecOps integrates security practices into this collaboration to ensure security is built into every stage of the process. The CI/CD pipeline ensures continuous integration and continuous deployment of code changes. Continuous integration involves frequently merging code changes, while continuous deployment ensures these changes are automatically deployed to the live environment. Secure coding practices are essential for building safe applications. OWASP, the Open Web Application Security Project, provides resources and guidelines to help secure web applications. Their OWASP Top 10 list highlights the most critical vulnerabilities developers should be aware of. Some proactive controls from OWASP to enhance application security include defining security requirements from the start, using security frameworks and libraries, securing database access, encoding and escaping data, validating all inputs, implementing digital identity with multi-factor authentication, enforcing access controls, protecting data everywhere using encryption, implementing security logging and monitoring, and handling all errors and exceptions properly. Security techniques include securing databases, validating all user inputs, using parameterized queries to prevent SQL injection, tokenizing sensitive data, and normalizing data to reduce redundancy. Injection vulnerabilities happen when attackers input malicious data that gets executed as part of a command or query. This can lead to data manipulation, disclosure, and even complete system compromise. Common types of injection vulnerabilities include SQL injection, cross-site scripting, command injection, LDAP injection, XML injection, HTML injection, and XPath injection. To enhance application security, use secure cookies, code signing, block lists or deny lists, and follow secure coding practices. Employ static and dynamic code analysis, manual code review, fuzzing, and set secure HTTP headers. Secure coding techniques include managing race conditions, handling errors properly, validating inputs, using stored procedures for SQL queries, obfuscating code, avoiding reuse of insecure code, managing memory securely, ensuring third-party libraries are secure, using secure SDKs, minimizing data exposure, and normalizing data to reduce redundancy. Session attacks exploit vulnerabilities in web application session management. This can allow attackers to impersonate users and gain unauthorized access. Proper session management and secure coding practices are essential to mitigate these risks. Other application attacks include session replay, cookie stealing and manipulation, cross-site request forgery, server-side request forgery, and remote code execution. Understanding these threats helps us secure our digital base against intrusions, much like ensuring a military base is protected from all threats.